All right, we good to go? Calculators work? Perfect. Okay, so again, I am not handing out a book. Okay, I'm going to hand everything to you, paper form. It'll be hole punch so you can just slide it in a binder. The very first page right here is your cover page. Okay, something neat so you know that this is actually a math binder. Okay, not something else. If you flip the page, you have your table of contents. Okay, I'm a very kind of OCD type person if you haven't been able to tell already. I need organization, and I know some of you are the same way. So at the end of the year, you are basically going to have a textbook at your disposal with every single problem worked out. That's a fantastic resource to have for any future endeavor. Okay? Now, instead of overwhelming you and giving you all 429 pages, I'm only going to give you chapter at a time. Okay? So you should only have Unit 0 right now. Okay? When we're done with Unit 0, I'll give you the next unit or the next chapter. Okay? And we'll eventually build. So there's your table of contents. At the beginning of each chapter or unit, you'll have kind of this table format that organizes the chapter for you. The first column is just my idea about how long each lesson or section is going to take us. Okay, this may change. Some sections might take us 3 days, other ones might take us 1. Okay, some of us might be pretty quick in here. We're going to get it fairly easily. Okay, but this is my idea about how long it should take us. So notice how today, day 1, okay, we're going to talk about functions and eventually becoming familiar with a calculator because we're going to use it a lot this year. I give you the objective, what you can expect, and then also the page numbers that go with that particular lesson. So today, we're going to probably be working on page 7, and then your homework pages are 9 through 12. Can you do me a favor and flip to page 9 for a minute? I know it seems like a lot, okay, 9 through 12, but if you look at pages 9 through 12, okay, page 12 is blank, so there's nothing there you have to do. And notice how I give you a lot of room. That's because you're going to put all of your work on this paper. So you shouldn't need a notebook for this class. You shouldn't really need extra paper for this class. The paper I give you is what you should need. If you need extra paper, that's fine. Okay, but I want you to try to work out everything on here. So it may seem like a lot of homework, but that's because I give you a lot of space to show your work. Does that make sense? Okay, so what we're going to try to do today is talk about function notation, and hopefully we kind of get to the calculator so we can get familiar with it. All right. We've heard of a function before, right? Can someone help me out? What is a function? What does it mean? What does it look like? Definition? Anything? First day jitters? No. No? We just don't want to say anything? Probably, right? All right. Function, one thing in, one thing out. Very easy definition. You plug in a number, you only get out one number. One thing in, one thing out. If you had a graph, okay, a picture, what could we use to help us determine if that graph was a function? Remember the test? Yes? Vertical line test. Thank you. Hold on. Isabella. Perfect. Okay, vertical line test. So we have different ways of determining a function. We can plug in numbers to see if we get a number out. Maybe we have a picture. We can drag our pencil across it, see if it passes the vertical line test. But we're basically going to be talking about functions, okay, things that hopefully we're already familiar with because these are kind of intro skills. So in terms of notation, okay, writing, math can be a little tricky because it's its own language, just like English and French and Spanish. But math has a very weird alphabet, if you will. We have very weird ways of writing things. So half the battle in a math class is figuring out what the heck does that mean? And we're going to talk about that this year. We're going to learn a different language. We're going to learn what math means. So this f of x, sometimes it's h of x, g of x, t of x, s of x. They could use any letter they want. But this is just telling you that whatever your equation is, that's a function. If you were to plug in one number, you should only get out one number. If you were to graph this, it would pass the vertical line test. So this is a way in math for you to know that it's a function. Okay, it's telling you that idea. So now that we know that this is a function, maybe we can start to evaluate it in a different way. We can start plugging in things. Can someone help us out with this first one? What do you think that f of -3 is telling us? What on earth does that mean? Good, Bert?
It means put in -3 where x is for 9 minus 4.
Perfect. Now, how'd you know this was an x value?
F of x.
F of x, right. Notice the way this is originally written. It's f of x. So whatever is inside those parentheses typically represents an x value. So this -3 is an x value. Hello? Hi. Sure, no problem. Yep, fine. Right? So, if this is an x value, let's go ahead and actually plug it into our function like Bert was telling us to do. We have 9 minus 4 times -3. Whenever you're plugging something in, it might not be a bad idea to use parentheses to show that you're replacing that variable. All right, order of operations, what's going to come first? Good, Bert? Which is a positive 12, yep. 9 plus 12? 21, perfect. Notice how it's a function. We plugged in one number, we get out one number. One thing in, one thing out. What does that 21 represent? It's what? F of x, right, okay. AKA, what an F of, yes. The y value thing. Nathan, same thing. F of x, y, same thing. So this is a y value. So we know what we put in, we know what we get out. We know the x value, we know the y value. Graphically speaking, okay, we can represent this function piece as a point. If we know an x value and a y value, we could perhaps write what the point would look like on that particular graph. Coming back to us? Probably never left, hopefully. All right. What about the next one? Slightly different. What is that 10 representing? Good, Nathan? The y value. All right. So if we were to plug in that y value into our function, where would it go? What would it look like? Remember, f of x and y are the same thing. They're equal to each other. Good, Matt?
Wouldn't it be 10 equals 9 minus 4?
There we go. Okay, it's not an x value. We can't plug it in for that x anymore. We said it was a y value, aka f of x. They mean the same thing. So in this case, let's go ahead and figure out what the x value would be. We can subtract 9, divide -4. We got -1/4. We plug in one number, we get out one number. One thing in, one thing out. So our point would look like -1/4, comma 10. If we had a graph, but we don't. All right, let's amp it up a bit. No numbers this time. F of h. What does that h represent? Can we make a connection? Stumped, okay. Did we have an example already with something inside parentheses. What did that represent? This time we're working with variables, no numbers. Kind of tricky, but they work the same way as numbers, because isn't a variable technically a number? They work the same way. What do we think this h is? Or what does it represent? The x value, yep. This is what you're going to plug in for the x. So if we were to plug in that h for the x in the equation, what would it look like? 9 minus 4h. Now can we simplify that any further like we could the first one? Not quite, right? Because these aren't like terms. One's a number, one has a variable in it. So that's actually as far as we could go in that case. What does the 9 minus 4h represent? It's a y value, yep. You plug in an x, you get out a y. You plug in a y, you get out an x. One thing in, one thing out, function. What would the point look like? Again, it's going to look weird because we're not really dealing with numbers. We have variables. Thank you, Cole. Perfect. Cole, right?
Yes.
Perfect. All right, last one. F of x plus 2. Again, variables, no number really. What about x plus 2? What's that representing? Say it again. It's inside parentheses. It's inside parentheses. That's an x value, yep. It's a little tricky because there's already an x in there, right? It's just telling us to take an x value and add 2 to it, but it's still representing an x value. So what we want to do is take x plus 2 and plug that in for the original x in our function. So if we're going to plug it in, again, it might not be a bad idea to use parentheses. Show that idea of replacing something. Can we simplify it at all? Clean it up? Yeah, what do you feel like doing? What's that called? What's that called? That's good, but what's that called? What'd she do? Do we know the name of it? Yeah? Distribution. Right, distribution. Perfect. So we got rid of parentheses, distribution. Can we clean it up even more? Like terms somewhere? Yeah? 9, negative 8, that gives us 1. Perfect. And I think we're done, right? No more like terms? So what is this 1 minus 4x representing? Y value. Perfect. So what would the point look like? X plus 2, 1 minus 4x. We on a roll?
Yep.
Yep, perfect. All right, so those are typical math problems, okay? Things that would normally take you just a little bit to figure out. We did 4 of them real quick, okay? But part of math is applying it, okay? Using it for a purpose. So what we're going to do is take some of these similar ideas and take a look at a word problem, okay? A free response type question. So we're going to use our calculator for some parts of this if we have to, okay? But let's use kind of our original calculator, okay? Our brain first. Let's take a look at this. Johnny enters a 7-day Pokemon competition. Have any of you ever played that Pokemon Go app? Do you know what I'm talking about? It's kind of making a comeback. I saw a commercial for it the other day. Anyone play it? Maybe you don't want to admit you play it. My husband played it a few years ago, and he was kind of obsessed with it. I don't know how it works, okay? I am clueless when it comes to that. But for some reason, he taped his phone to a remote control car and was driving it around our house or like on our sidewalk. Isn't it like how you need to exercise or something or go walking around to get things? Yeah, he's crazy. I thought that was really weird. Anyway, Johnny enters a 7-day Pokemon competition. The function, okay, function, one thing in, one thing out. The function below models his total cards over the tournament. Now, this function they give us is a lot more involved than the simple one we had at the top. Okay, we have more variables to work with. That doesn't mean it's difficult. It just means there's a little bit more going on. So can we first, perhaps, identify what these different variables mean? Okay, yes, it's x value and y value that we were talking about, but now we have a scenario behind it. Okay, can we relate this function to the scenario? What do you think the c of t represents? What do you think the t represents? Could you take a guess? Go ahead, Bert.
I would say that t is the x value.
T is like an x, okay, which means c of t is like a y. Perfect. What was that?
I had that backwards.
You had that backwards? I don't think
I
you...
had put t inside parentheses.
Oh, it is. Okay, so you could say c of x if you wanted to. That's fine. The t is like an x, yep. What about using some words besides x and y? What does c of t represent in this problem? What about t? We're talking about Pokemon, we're talking about days, we're talking about cards. Go, Cole.
Total cards.
Okay, so this is representing how many cards, total cards that Johnny has. What about the T? What do you think T represents? Go to Isaiah. Time, yep, and our time unit in this case is days. Time or days, perfect. All right, so now that we have that set up, let's see what's asked of us here. What does C of 3 mean? Okay, not meant. And find it. What's that notation telling us? Okay, so if we're substituting the 3 in for t, that means the 3 is representing a day. Okay, so after 3 days, if we were to plug in 3 and eventually get an answer, what do you think that answer would represent? The number of cards, right? That's your y value. You plug in an x, you get out a y. In this case, you plug in a day and you get out a card. So after 3 days, we're going to figure out how many cards Johnny has. I'm abbreviating. How many cards Jay has. So let's go ahead and find it. Okay, on the 3rd day of this competition, let's see how many cards he has. So what we're going to do is go ahead and plug in 3 for all of those T's. Now I know you have a calculator in front of you. Might be tempted to go ahead and use it. But let's see if we can maybe use our old-fashioned one. 3 cubed, 3 times 3 times 3? 27. 3 squared? 9. 2 times 3? 6. All right. 1/3 times 27. 9, aka 27 divided by 3. We got 9. And then 2 times 9, 18. Let's see, -6 plus 50, 44. So how many cards does young Johnny have? 35. 34? 35. 35 cards. Perfect. All right, very similar to the 4 problems we did at the top, right? This time we just have a word problem or a scenario behind it. Okay, but we can do this. Let's check out 2. What does C of t equal 40 mean? And this time we're going to estimate it. Roughly, we're going to find it. What does the 40 mean? If we were to plug it in, where would it go? Good, Bert? Okay, so when Johnny has 40 cards, what are we trying to figure out? If you plug in a card, what would your answer be? A day. What day is it? Does that make sense? Okay, what day is it? So, what would our equation look like if we were to plug in 40? We'll do that tomorrow. All right, we didn't get to the calculator part yet, but when you come in tomorrow, go ahead and grab one, okay? Please put them back on my door.